Well, good morning, everyone. Welcome to Hugh Ross's Paradoxes class. I'm Mark Perez. We have this first 15 minutes where it's a Q&A where anyone can ask any questions you like. After the first 15 minutes, Hugh will do a discussion lasting about a half an hour. And then after that, anyone who has questions can continue to ask questions. If you had questions from last week and you didn't get them answered, please post them this week. You can do it right now if you like. And let us know that you didn't get your question answered last week, and we'll put you at a higher priority. So with that, I'll look at the questions, and it looks like we're already starting to get some questions coming in.
Right, and we got Ross here, so you can, let me see if I can make him a co-host.
All right.
Yeah, okay, I just promoted him to a panelist, so you should be able to make him a co-host.
Okay.
Yep.
All right, so I'm going to hold off on asking these questions and let Ross take care of that. So let me promote him up here.
There we go.
Okay. Okay, Ross, are you in, or is he not on?
Saw him there for a moment.
Okay.
You guys hear me now?
Yeah, we can.
Okay.
All right, your video's off, Ross, but your voice is on.
Well, I don't have a switch, anything to click on to open the video.
Okay. Can you access the question and answer?
Okay, I just promoted him too. Okay.
Okay. I think I'm fully human now. Can you see me?
Yes,
Yes.
I can see you.
We already did the opening announcements, so we're into Q&A now. So if you'd like to start the Q&A, Ross, please have at it.
I will, if I can find the questions. I'm really struggling here. Mark, you've done really well. Why don't you take the first couple of questions? And
Okay. All right, I'll take the first two, and then we'll get going. So
sounds good.
The first question is from Doug from Monrovia, and he asks, the Large Hadron Collider is the world's largest and most powerful particle accelerator. It first started up on 10 September 2008 and remains the latest addition to CERN's accelerator complex. So why was this built? Have there been discoveries from it that you point to the existence of God in the Bible at all?
Well, it was built to try to find the God particle for one, and they did find that after about 2.5 years of searching. And that's the particle that actually bestows mass on the particles that do have mass. And so that was a major prediction, what was called the standard particle creation model. And so that was a major success. Where it's going now is they're hoping to be able to find axions. And axions are believed to be the most populous of all the particles that make up exotic dark matter. That's matter that doesn't strongly interact with photons or with light, which astronomers believe makes up about 23 to 24 to 25% of all the stuff of the universe. It's about 6 times more abundant than matter that does interact with light, such as protons, neutrons, and electrons. I actually think astronomers might find axions first. There's studies going on right now looking at white dwarf binary stars, and apparently they're cooling so much faster than we would expect that the cooling was merely thermodynamic. So the astronomers believe that there may be axions that are decaying, which is causing the cool more rapidly than otherwise. One paper's been published saying that they think they found axions, but the signal to noise ratio was a little bit below 4, which is really not enough to claim that you've made a discovery. But the studies are going on. So yeah, there's a race going on now to see whether astronomers studying white dwarf binary stars are going to find axions first, or the Large Hadron Collider is going to find them. There actually is a proposal to build an even bigger particle accelerator. It'll be even more expensive, but the funding is not yet secured. And I think China is one that's wanting to put significant resources towards that. But again, nothing official yet.
Great, thank you. I'm going to do one more before Ross gets on. Stephen Posta from Spring, Texas asks, Wednesday, astronomers released a spectacular image of galaxy NGC 4217. It contains huge magnetic superbubbles of gas, giant loops, and an X-shaped helix magnetic field structure that spirals upwards into the galaxy's halo. Does this radio image further support your understanding of the cosmic web intricately woven through the universe?
Well, the cosmic web is really dependent of, in terms of trying to get an understanding of that. You get that by looking at the intergalactic magnetic fields, because there's a belief that they actually go all the way back to before galaxies formed. They're referred to as primordial magnetic fields. And so, yes, what we see in this particular galaxy, those magnetic fields are being generated by the activity within that galaxy. Probably what's going on with a supermassive black hole. Future papers will tell us for sure. And you'll find two articles on primordial magnetic fields and how they tie in with the cosmic web in my Today's New Reason to Believe blog. Go to Today's New Reason to Believe on reasons.org and put primordial magnetic fields into the search engine. That will pop up. I also got another article independent of those two on the cosmic web. So, and I've been asked if I could actually talk about that. I did a class here. So if you actually scroll back at reasons.org, you should find a recording on the cosmic web. And I got some really neat visuals that go with that. That you probably have to go back about 6 or 7 months before you find that recording. Maybe we can even post it on the website, exactly where that is.
Great. Thank you, Hugh. I'll take over the questions here. Chris Thompson from Anchorage, Alaska asks, Hugh, in the book of Ezekiel, he writes of a, quote, wheel within a wheel. What is your interpretation of what this is?
Well, if you read that text, it's not just a wheel within a wheel. Apparently, there are eyes going all the way around that wheel, and the wheels intersect one another. And it says the creatures move based on these complex wheels. And I discussed this in my book, Beyond the Cosmos, basically making the point, I believe that Ezekiel was seeing a phenomena. Most Bible scholars believe that the creature is actually a cherubim, which is a high order angel amongst God's righteous angels. And that what Ezekiel was seeing was this angel manifesting extra dimensional phenomena. Because the idea of a wheel moving inside of another wheel where they're at different angles with eyes all around them. And then you notice Ezekiel is saying, Lord, what am I seeing here? So it's something that he's really struggling, just trying to comprehend. And that's why I speculate in Beyond the Cosmos. He was seeing an angelic being manifesting to Ezekiel an extra dimensional phenomena, which would be kind of mind-blowing for Ezekiel. And clearly when you read the text, by the way, read not just Ezekiel 1, but Ezekiel 10, because both those chapters deal with that. If you put the two chapters together, you do get a clearer picture of what he was experiencing.
Thank you, Hugh. Another question from Stephen Posta in Spring, Texas. He says, a couple of times in recent weeks, you've made a mention about man's inability to go to Mars until we figure out a way to prevent prolonged radiation exposure. Could you please spend a couple minutes to unpack a detailed explanation of what the issues are and what would need to be done in order to either reduce or eliminate this exposure?
Okay, and once again, if you want to find a thorough answer, they can go to reasons.org, my blog, Today's New Reason to Believe, and just put in the search engine gut-wrenching space travel. It'll pop right up. And I use that title because what they did is they took mice, and the reason they used mice have a digestive tract. That's a really good analog for the human digestive tract. You may have noticed that mice and rats seem to do really well eating anything that we can eat. They're omnivorous, and that's because they have a digestive tract that's like ours. And so what they did is they did an experiment where they exposed these mice to the kind of radiation that we humans would experience once we got outside the magnetosphere of our Earth. Our planet Earth is shielded by, there's a magnetic shield generated by the Earth's magnetic field. And what that does is it deflects away, especially the heavy nuclei, fast moving cosmic rays. And those heavy nuclei, by heavy nuclei, anything like a helium nucleus or heavier is in that category. Most cosmic rays are protons and electrons, and they don't do nearly the damage that, say, an oxygen or an iron nucleus would do, piercing through your body. And so what they did is they raised these mice under laboratory conditions where they exposed them to that kind of radiation, and discovered that they were noticing that the mice were experiencing distress even after just 30 days. And by 3 months, their digestive tracts were basically destroyed. They weren't dead yet, but what they noticed were the mice simply were not able to function anymore. And by the end of 6 months, they were developing serious tumors throughout their digestive tract, and then they would die. And so the point is that if you try to send astronauts from Earth to Mars, they're only going to be shielded by the Earth's magnetosphere for a few days at most, maybe even just 1 day, but at most 3 days. And then once they get outside that magnetosphere, they're exposed to this radiation. And the article is basically making the point, they will suffer the same consequences and the same timescales as the mice. And the fastest that we can think of getting to Mars with current technology is 6 months. So it is, even before they get to Mars, you're going to have astronauts that are either be dead or they're not going to be able to function. So, why send astronauts? And then people have said, well, maybe what we need to do is build a magnetic shield around the spaceship. And that's where I mentioned in the article. By the way, this wasn't in the research paper, but it's something I added, was that we scientists have not been successful at building a sufficiently stable magnetic bottle to make hydrogen fusion work. I mean, that's kind of the goal of these giant tokamaks, but it's like they're even struggling trying to maintain a stable magnetic bottle for 1 second, a sufficient magnetic bottle that could protect you from that kind of radiation. And these bottles are really tiny. When you scale up to make a bigger one, it's much more challenging. You say, well, why is the Earth's one stable? Well, Earth's gravity is a stabilizing factor. And so, yeah, if you were to build a really big spaceship that's a large percentage of the mass of the Earth, maybe you could make it work. But now you're talking a really expensive spaceship. And, it'd be cheaper to make an artificial planet than to build such a spaceship and try to get it to Mars. So in all practical purposes, sending humans to Mars is out of the question. It's not going to happen. I'm not saying there isn't some future technology, but there's no conceivable technology we can even dream about that would enable us to protect a spaceship large enough to house astronauts and keep them from this devastating gut-wrenching radiation. But yeah, you can go to reasons.org. You can find that article and get more details.
Thank you, Hugh. I don't have any questions on the question box. Mark, do you have any left over from last week, or do you have a brilliant question yourself that you can ask Hugh?
Did the question from Karina get already answered?
I don't, on my screen, I have no open questions.
Okay, I have an open question from Karina. And what I'm going to try to do is let her ask the question and give her a voice right now, because she's an astronomer.
Okay.
So I'm going to allow her to talk. Karina, if you'd like to talk, Hang on just a second.
Yeah, you need to promote her to a panelist. There we go.
Okay, Karina, if you unmute, you can ask your question by voice.
Hello, can you hear me?
Sure can.
Yes.
Hi. No, I just want to ask some question about last week. Dr. Ross, he was talking about the migrations of the giant planets on the solar system. And he commented on that this migration stopped once planets reach a part of the disk where there was no more gas. But I just wanted to ask or add a comment that according to planet formation theories, the radial drift is in that sense not stopped by the lack of gas content, but by pressure bumps created by the gas distribution. So the gas has a gradient, a pressure gradient, and this material, gas and dust, get trapped in these pressure bumps. And that is where grain growth is drive. I mean, grains start to grow and form planetesimals, and then it creates planets. So I just want to ask how that fits into what Dr. Ross said. I don't know if it's this migration of giant planets occurs later or just really early on the planet and in the planetary system. Thank you.
Karina, thank you for making that comment, because what I said last week was kind of a simple overview. There's actually many papers being published now on what stops these planets from migrating. We do observe that they do stop and they get into these stable orbits. And so somehow the gas, dust, pebbles and planetesimals are interacting with gets cleared out. And there's a variety of theories like the one you mentioned and how they get cleared out. And incidentally, not all the planets stop. So there's plenty of evidence, for example, at least the smaller planets, a lot of them wind up getting consumed by their stars or getting scattered out of the planetary system. And so this is an ongoing area of significant research, trying to understand, okay, we do know these planets migrate inwards. What exactly causes them to stop? We know if there's lots of gas, dust, and pebbles and planetesimals in the vicinity, they keep migrating. There's a variety of theories of how there's a gap produced that stops it, or they wind up draining all the gas and dust that's there, or there's some interaction with the planets that stops them from drifting in. That's the papers I've been reading. If you've been reading some others, I'd love to hear your comments on that. And yeah, one important caveat is they don't all stop. Some of them go all the way into their stars, and or they stop, but they scatter a lot of the small ones. In fact, most models understand that when these migrations occur, the small rocky planets that form close to the stars, in fact, I read one paper which said we can anticipate that the majority of these rocky planets, as these gas giants and Neptune type planets migrate inwards, they're going to find themselves being sucked into the star or completely scattered out of the system. So it'll be interesting to see where the research goes here. But yeah, you want to make some follow-up comments?
No, it's okay. Thank you. Yeah, you're right. I mean, that is also an open issue right now. We don't really know everything about what stopped the radial drift. So yeah, thank you.
Oh, you're welcome.
Okay, Hugh. Well, it's 10:48. Let's get started officially with class. I want to welcome everybody again to this Paradox class. Mark welcomed you before, so you should all feel doubly welcome. We're very glad to have you here. I'd like to just take a moment and recommend a book. This is called Reflections on the Existence of God, Richard Simmons III, not to be confused with the exercise guy. This is a really excellent layman level book on Christian apologetics. It's a really good overview. He's got like 55 chapters, but each chapter is only about 3 to 5 pages long. You can do a chapter in 10 minutes, but it's remarkably deep. Not a lot of 6-syllable words, and it's very well written. So I would recommend it to anybody who wants a really good overview of all the evidence there is out there for God's existence, or as a gift that you want to give to somebody who has questions about that. And I'm curious, Hugh, do you know Richard Simmons?
No, I don't. I'm not aware of the book.
Yeah, it just came out a little while ago, and I'm quite a ways through it. So, Reflections on the Existence of God, Richard E. Simmons III. And that's all I have to say. Hugh, why don't you open us in prayer, and we'll get started.
Okay. Well, Father in heaven, we thank you for this technology that allows us to engage in this way, meeting together, as you say in Hebrews 10:25, in spite of this pandemic. And Lord, we do pray for all those that are working on coming up with a therapy to help people who get the COVID-19 and help them to recover without significant health consequences. We also pray for those that are working on the vaccine. And Father, we thank you that a lot of your people are involved in this research. We ask that you particularly bless them with the necessary wisdom and grace. And Father in heaven, we ask your blessing upon this time we spend together. Lord, I pray that we would open up our hearts, our minds, our spirits to receive more of your love, more of your light, and more about your love, life, and truth. In Jesus' name, amen. Okay, I'm going to begin with a suggestion. I mean, we've had to turn off all the videos except for the panelists because of this. We got Zoom bombed one of the times we did this. This is a public event after all. But one of the things I'm seeing in the attendee list is some of you are actually indicating where you're from. And I'd like to suggest as many of you as feel willing to do so, that you would also indicate where you're participating from. I think it'll help all of us feel a little more sense of community. So take advantage of that if you're willing. And a little word too where we're going in this class. The church where I've served on the on the pastoral staff. I've been on that staff now for more than 4 decades actually, and I've been part-time ever since I launched Reasons to Believe. But they're asking me to repeat and update a series I did decades ago where we went through the first dozen chapters of Genesis and basically looked at it verse by verse and went through it in the context of what the Bible says and what the science says. I've got a lot of updated material. In fact, I'm going to be, not this book that I'm working on now, on designs of our galaxy and star, planet, etc. But my next book will be on really doing a thorough job on going through what the Bible says about the flood. Anyway, the church leaders have asked me if we could please do this, where we basically break it up into bite-sized pieces of, say, 4 to 8 weeks, get it all video recorded, but include the audience participation and get that posted on several public websites. So that's the goal, but they've asked me to hold off on that until we can actually meet in public. And we have a room where we can do that, a very large room where we can be socially distant from one another. Reasons to Believe has actually volunteered their conference room for us to do that. So as soon as this pandemic drops enough where that's possible, we're going to move into that mode. We're still going to keep the Zoom feature going. We're actually going to have cameras showing me and the people in the class, and then we'll allow others to participate as well. So that's what's coming. In the meantime, I'm filling in with material that's going to be going in my next book. It's got the tentative title, Interior Designs. We're looking at the interior designs of our super galaxy cluster, our galaxy cluster, our galaxy group, our galaxy, then going down into our star, our sun, the planets, the designs we see in the comet and asteroid belts into the Earth, And we're going to be looking at the different interior layers of the Earth, the crust, the upper mantle, lower mantle, and the upper and lower cores of the Earth. And basically making this a fine-tuning argument. And for the last 2,000 years, the agreed upon most powerful scientific evidence for the God of the Bible has been the fine-tuning argument, the evidence for design. And what's remarkable about that argument is how it gets increasingly more persuasive as we learn more and more about nature. A principle we see in both the Psalms and the book of Job, that the more we learn from God's second book, the book of nature, the more evidence we get for the existence of God, the character of God, his redemptive plan, and for the inspiration of his written book, the Bible. So that's what we're going to be doing. And if you've not been involved in the last few months, what we've been doing is basically looking at the planets that make up our solar system and making the point that, well, let me actually get this started for you. I'm going to take share screen because I want you to be able to see my visuals. And here we go. So this is the first slide. I always start with a slide. Basically let those of you that are new realize if you don't get to ask a question today, you can post questions to me. And you can do that to every member of our staff scholars at Reasons to Believe. We all have a Facebook and Twitter page where we take questions. We don't guarantee to answer all your questions, but so far we've been pretty well doing that. So it's Facebook and Twitter. I'm not on Instagram, but the ministry is. And Reasons to Believe maintains a 24/7 YouTube channel. You can subscribe for free, and you'll see all that at reasons.org. So with that, a couple of books that might be relevant to what we're talking about today is Weathering Climate Change. You can get a free chapter at reasons.org/Ross. And yeah, Canada is a place that is experiencing climate change more dramatically than anywhere else in the world. And it's not just climate change from year to year, even season to season. So yeah, the background is a shot of my wife in southern British Columbia in the first week of August, where, believe it or not, you can get a foot of snow falling in a single day. But the next day it jumped up to 80 degrees Fahrenheit. So, and then the book, Always Improbable Planet. But this is a verse I shared last week. The earth is the Lord's and everything in it, the world and all who live in it. This is a good fine-tuning verse, basically making the point when we examine our planet Earth, we're going to discover all kinds of features that testify that it's the Lord that created the earth, it's the Lord that designed the earth, it's the Lord that filled it with all the plants and animals and life forms that we see, and how this actually extends into everything else we can see in the universe. That's the theme that's going in my next book. It's not just the earth, literally every planet in our planetary system has been fine-tuned, has been designed to make possible advanced life on planet Earth. That's one of the big discoveries of these thousands of planets they found outside the solar system. In discovering them, they actually came up with a byproduct of just how specially designed Jupiter and Saturn is, and all the other planets that make up our solar system. And this morning, I want to jump into how we now understand through the discoveries and research we've been doing in exoplanetary systems, how it's not just the planets, but every one of the 5 asteroid and comet belts has been especially designed to enable advanced life to be possible on planet Earth. And this is where we left off last week, basically going through the catalog of exoplanetary systems. And as of this morning, there are 4,301 planets that have been confirmed to exist beyond the 8 that we know. So that makes up a total of 4,301 and 9 known planets. And the number of exoplanetary systems is 3,000. You know what? Let me actually exit this. I'll give you the exact number. Yeah, here we go. 3,177 known exoplanetary systems. That's of this morning. And what I shared last week is that the majority that planets that have a lot of gas, like Jupiter, Saturn, Uranus, and Neptune, we call the gas giants, the Neptune-like planets, and then the super Earths, which don't exist in our solar system. Super Earths are planets that are more massive than planet Earth, but not more massive than 10 times the Earth. These are gas-rich planets. They can only form beyond the ice line, and that's the distance from the host star where gases like carbon dioxide, water, carbon monoxide, and methane will freeze. That happens when the temperature is below 150 degrees Kelvin. And in our solar system, the ice line is about 3 times the distance away from the sun that the Earth is. So this is where these gas giant planets and super Earths and Neptune type planets can form. But as we look in the exoplanetary catalogs, 83% of these known gas-rich planets orbit their host stars way inside the ice line, which means they must have migrated inward. And the discovery that so many of these gas-rich planets were orbiting close to their host stars, well inside the ice lines of those host stars, is what led astronomers to determine the mechanism by which these stars migrate inwards. And it's basically gravitational interaction with the gas and the dust, the pebbles, rocks, and the planetesimals. Planetesimals is any rock bigger than a kilometer in diameter that remain while planets are still forming. And so this gravitational interaction causes these planets to migrate deep interior to the ice line. However, there's 17% where this doesn't happen. And in that case, what we notice is they either stay put or they actually migrate way out. In fact, we've now found these gas giant planets literally 50 to 100 times farther away from their host star than Neptune and Uranus are away from our host star. And they've discovered that if you get more than one of these gas giants forming, it's actually possible for them to migrate outward rather than inward as they gravitationally engage the remaining gas and dust and rocks that are in the planetary system. Also, as they gravitationally interact with one another, they get scattered outwards. One of the things that they've discovered is that planets that are orbiting exterior to the ice line typically have really large eccentricities. We defined that last week. That's referring to the shape of the orbit, how elliptical it is. And if it's highly elliptical, that means there's a much higher probability for a gravitational scattering event where one of these big planets interacts with another one and causes it to be kicked far out into the planetary system. So that's 17% where they either don't migrate at all. If all the gas and dust is gone, there's no more rocks around, they're not going to move, or they wind up getting tossed way out. And the exception, as we mentioned at the end of last week's discussion, is what's happening in our solar system, where you got the gas-rich planets migrating inward, and before they get to the ice line, they stop migrating, they reverse direction and migrate outward. And how this is referred to the Grand Tack model. And it takes so much fine tuning to make it possible for these planets to stop, turn around, and reverse that astronomers, in fact, I'm going to share some quotes with you today, are persuaded that we may be living in the only planetary system where this has happened, or at least happened to this degree. But it's this inward migration, stopping before it reaches the ice line, and then moving back. Matter of fact, where it stops needs to be fine-tuned in order for life to be possible on our planet Earth. And I think I briefly showed you this slide last week, which basically shows you in detail the migration history of Jupiter, Saturn, Uranus, and Neptune. And actually, there's a fifth planet involved, a planet slightly less massive than Uranus that actually got kicked out of our planetary system, although some astronomers believed it didn't get completely kicked out, but got tossed out to about 50 to 100 times the distance from our sun that Neptune is. We actually see kind of an overlapping knot of orbits of the larger asteroids in the Kuiper belt and in the inner Oort cloud that tell us that that may be caused by a planet about 10 times the mass of planet Earth that's orbiting the sun 50 to 100 times more distantly than Neptune orbits. Neptune orbits at about 3 billion miles away from the sun. And the units I have here are astronomical units. I'll remind you, 1 astronomical unit is a distance from the sun to the Earth. And so what you see here is the starting distances for Jupiter, Saturn, Neptune, and Uranus. What's interesting is Neptune was closer to the sun than Uranus was in the beginning. And so what we see is that we have Saturn orbiting the sun fairly close to where it orbits right now. But this is where we have the highest density of gas and dust and rocks and planetesimals. And so it has a faster inward migration than Jupiter does. And Jupiter starts just slightly more distant from the sun than where it is now. And it migrates, this is the latest model, it migrates to within 2 astronomical units of the Earth. And so it actually goes inside the ice line, but not close enough to get to the orbit of Mars. But by going to 2 astronomical units, reversing and going back out to where it is now at 5.2 astronomical units, that latest wrinkle actually explains how it is that you get the configuration that we observe of the 4 rocky planets in the solar system. In particular, how we can explain the mass and the orbit of Mercury and the mass and the orbit of Mars. Mars was the most challenging problem. Earlier versions of this model basically had Jupiter coming in to about 1.5 astronomical units, but in that case, you wind up with a Mars that's 50% more massive than the Earth. And so by adjusting it to 2.0, you can actually get Mars the mass that it is right now. And incidentally, you don't want Mars much bigger than what it is, because now it would pose a gravitational problem for the Earth. But yeah, typical models, you expect the rocky planets to be more massive as you go away from the host star. That works for Mercury and Venus and Earth, but now we have Mars at just 1/9 the mass of the Earth. And it's thanks to this grand tag movement of Saturn and Jupiter. But what happened to Neptune is that we've got Saturn migrating at a much more rapid rate than Jupiter does. And so what happens is with Saturn moving at a more rapid rate, it reaches a point where it makes exactly 2 orbits around the sun for exactly 3 orbits of Jupiter. That's referred to as a 3-2 mean motion resonance, which means that you're going to get these regular times where the gravity of Jupiter and the gravity of Saturn line up to cause disturbances throughout the solar system. And originally this model had it as a 1-2 resonance. A 1-2 resonance does not produce the orbital configuration of the small rocky planets. The 3-2 does. And so we got Jupiter making exactly every 3 orbits for exactly every 2 orbits of Saturn. And it's that 3-2 resonance that actually causes a reversal in the migration. And we actually have Neptune coming very close as a result to either Jupiter or to Saturn. And what you see there on that purple line may not be precisely accurate at about 100,000 years after this all begins. That's still being researched in the literature. However, what is agreed upon is that when it has a close encounter, either with Jupiter or Saturn, it gets tossed way out into the other part of the solar system, crosses the orbit of Uranus, and winds up about 30 times the distance between Earth and the Sun from the Sun. And so what is well established, what you see after that close interaction. And so now, as I mentioned quickly last week, the exact start time of this grand tack is still being considered in the scientific literature. Some models appeal to the grand tack to explain the late heavy bombardment, which took place when that was about 3.9 billion years ago. But another version of the grand tack has this happening quite early when the solar system is only about 50 million years old, up to 100 million years old. And the scientific literature is now strongly favoring an early date for the grand tack and how it actually fits in to the moon forming event, where we got the 5th rocky planet. Our solar system actually starts off with 10 planets, 5 gas-rich planets and 5 rocky planets. One of the gas-rich planets gets tossed way out or completely away, and then a 5th rocky planet. And by the way, a paper just got published in the past few weeks, now giving us an accurate view of how massive this 5th planet was. It goes by the name of Theia, and there used to be a debate in the scientific literature. Is it 11% the mass of the Earth, or it could be as much as 40% the mass of the Earth? A new constraint has just been published, which tells us that the planet Theia is between 11 and 15% of the mass of the Earth. And to give you some comparison, Mars is about 11% the mass of the Earth. So the size of Mars, or maybe almost 50% more massive than Mars, but not more massive than that. And one reason why they were thinking maybe it could be as much as 40% is that we were actually seeing that the composition, the elemental composition of the moon and the Earth appear to be identical. And to make them identical, it's really difficult to do that unless the bodies are the primordial Earth and the primordial Theia are close to being the same mass. But again, there's new research showing, yes, if you look at the upper mantle of the Earth and the crust of the Earth, compositionally, it's very close to what we see in the moon. But the deep interior of the mantle, we do see a significant compositional difference. And so that allows Theia to be much smaller, and dynamically things are actually fit a smaller mass, as this new constraint paper points out. And so we could have the heavy element material basically going into the interior of the Earth, the lighter material in the crust and mantle of the Earth and into the moon itself. And I've just written a piece on the moon that we might actually bring into this class about how big it is and how it has a very low density given its mass and given where it is in the solar system. But that actually plays a crucial role in making possible the advance of some significant scientific discoveries. So I'm actually preparing a talk on that right now and get that ready fairly soon. So, but what I want to do now, this is all new material here, what it takes to make this model work and why astronomers are increasingly being persuaded that this may be a unique feature of our solar system and may explain why, in spite of the fact that we've now found more than 4,300 planets outside of the solar system, none of them are even close to matching the characteristics of any of the 8 planets in our solar system, and how we now know that actually every one of the 8 planets including Mercury. Actually, the mass and the orbit of the moon play a role in making possible the stable orbit system we see in our planetary system. But this inward migration, where it stops at just the right distance and reverses and moves back out, is only possible if the most massive gas giant planet is the closest to the host star, and then the second most gas giant planet is the second closest to the host star. In fact, we now know that the original orbital distances from the host star must be fine-tuned for both Jupiter and for Saturn. You can have planets existing beyond Saturn, but for this model to work and to explain the configuration of the solar system, any additional gas-rich planets have to be significantly less massive than the second most massive gas giant, which is indeed the case in our planetary system. Again, this only works if the masses and the original distances between the two most massive planets are fine-tuned. A new research paper is coming out where it basically says that the eccentricities of Jupiter and Saturn likewise must be fine-tuned. They must begin more eccentric than they are now, and that actually fits. If you got planets forming that far from the host star, there's a very high probability that they will be eccentric orbits. But the eccentricity, we now know, a higher eccentricity is actually a crucial feature to make this model work. Only possible, the initial orbits of Jupiter and Saturn are precisely fine-tuned, both the distance and the shape of the orbit, and only possible the time scales for the formation of Jupiter are fine-tuned. And papers who are basically making this point are saying the timing of when Jupiter and Saturn form relative to the exhaustion of the gas, the dust, the pebbles, the rocks, and planetesimals in the protoplanetary disk, that's what needs to be fine-tuned. And then how much time it takes for the planets to form in that context. So the timing relative to the protoplanetary disk and what's happening in the protoplanetary disk must be fine-tuned, and the time over which the planets form must be fine-tuned to make this work. This is all additional evidence or discoveries that have been made indicating just how much fine-tuning must go in to make all of this work. Now, what are the consequences of the inward migration, the stopping and the reversing that we see in our solar system? Is that the inward migration drives short period planets into the sun. And because what we're seeing with exoplanetary systems is that almost all the rocky planets, in fact, all the rocky planets, except those in our own planetary system, orbit their stars closer than Mercury orbits the sun. In fact, the vast majority orbit way closer than they orbit the sun. Typically, less than 0.1 astronomical unit. To put this in context, Mercury orbits the sun at a little bit less than 0.4 astronomical units. And so the vast majority of these rocky planets are orbiting much closer to the host stars. And then we look at our solar system and we don't have any that are orbiting close. And so this grand tack actually had the consequence of driving these short period rocky planets into the sun. And this actually helps because we're seeing an elemental composition in the surface and the atmosphere of the sun that cannot be explained unless it got enriched with these rocky planets being sucked into the sun. So it actually explains one of the features that we observe in the sun. So that's one consequence, and explains why our planetary system is so different, where all the rocky planets are orbiting far away. And so yes, it explains why the sun is so rich in refractory elements. These are basically the metals. And if you got rocky planets being driven into the sun, they will be very rich in metals, and explains why the sun has that. And there's actually research going on as to how that may explain why the sun is as magnetically stable as it is, and why the sun, compared to all sun-like stars that we've been able to observe, has such an incredibly stable luminosity. I actually wrote a blog on this a few weeks ago. You'll see it at reasons.org, basically demonstrating that when we compare our star to the sun to the most solar-like stars, we find the sun's luminosity stability is at least 5 times better than we see in the most sun-like stars. And of course, that's a real benefit for advanced life on planet Earth, that we are orbiting a star that has such exceptional luminosity stability and an exceptionally low rate of flaring activity. This grand tack would also eradicate any super Earths or warm Neptunes. That's one of the things we discussed. We look at exoplanetary systems. We see that they're very abundant in super Earth planets and warm Neptunes. Warm Neptunes would be Neptune-sized planets that are orbiting their host stars closer than Mars orbits the sun. And they would either get scattered out, the vast majority of them get scattered out. There's a possibility that some of them might get sucked into the host star, but the majority of them would simply be scattered out of the system and would deplete the remaining interplanetary debris of volatiles, and explains the high refractory to volatile ratio of Mercury, Venus, Earth, and Mars. And what I mean by volatiles, these are elements or compounds that are in a gaseous state at relatively high temperatures. So this would include carbon, oxygen, nitrogen, would include hydrogen and helium. It would include carbon monoxide, carbon dioxide, methane, water. These are volatiles. But as we see the inward movement of Jupiter and Saturn, it basically depletes the debris in the interplanetary disk of these volatiles, and would explain why the planets, the rocky planets in our solar system, are so rich in refractory elements. And how we know that they're super rich is that their densities are greater than the few rocky planets that we see orbiting more distantly from their host stars. So it tells us there must have been an enrichment event. This would explain that enrichment event. And it eradicates the E-belt of asteroids. On my Facebook and Twitter page, I posted some visuals of that. We'll get to that in a minute as to what this E-belt is all about. Thins out and restructures the main belt of asteroids, explains the property of the Kuiper belt. That's the belt of asteroids and comets that are orbiting beyond the orbit of Neptune, but not more than about 50% further away than Neptune would be. But the very latest, this just got published, is that this grand tack model for the solar system actually explains the detailed properties of the Oort cloud. This is the most distant of the 5 asteroid and comet belts in our solar system. Goes out to at least 2 trillion miles away from the sun. And we actually been able to observe a few of the larger objects in the Oort cloud, but we now understand that the Oort cloud is by far the biggest of the comet and asteroid clouds or belts that we see in our solar system. So that's the latest. I may talk a little bit about that next week, but let me talk about this E-belt. Okay, this is the belt of asteroids between Jupiter and the orbit of Mars that existed before this grand tack movement of Jupiter and Saturn. And incidentally, I'm not ignoring Uranus and Neptune. It's just that they didn't migrate inward hardly at all. Just a very slight inward migration and then a very big outward migration. It's Jupiter and Saturn that experienced the greatest inward migration. But this is what the belt looked like. And actually, this is underestimated. The belt of asteroids between Mars and the present orbit of Jupiter would have been much more populated than what we see here. We're looking at it about 100 times more asteroids than what we see in the asteroid belt, the main belt of asteroids. Incidentally, this main belt is probably the least massive, the least populated of the asteroid and comet belts. But it's called the main belt because it's the first one that was discovered. It's the closest to us. It's the easiest to observe. And so this is what it started out as. And then we've got Jupiter. This shows you the inward migration of Jupiter to 2 astronomical units from the sun. We got Mars orbiting the sun at 1.534 astronomical units. And so that red line shows you where Jupiter started, where it migrated into this belt, turned around, and then migrated out to where it is right now. The E belt refers to the belt of asteroids that's between about halfway out from our star, the sun, to the present orbit of Jupiter, all the way into the orbit of Mars. And again, what I'm showing you here doesn't do it justice. I was creating this yesterday morning and didn't really have time to really fill it all in, but there would have been many more asteroids than what you see here between the orbit of Mars and halfway out to Jupiter. But basically, this inward migration of Jupiter eradicated the E-belt, simply caused a huge scattering of all of these objects out. And yes, our planet Earth may have benefited from that, in that we probably received a lot of collisions. And many astronomers, and there's actually a lot of papers published to the effect that this inward migration also is responsible for the planet Theia colliding with the Earth. But we don't think it's just that one planet. We think a number of these asteroids also wound up colliding with the Earth. In fact, some of them may have been colliding with the new forming moon that came about as a result of the merger between Theia and the proto-Earth. But the bottom line is, once this is all done, this is all we got remaining. So the E-belt is completely eradicated. This is the belt that remains now. Notice it's much less populous than it was. And then we also have a bunch of asteroids that share the orbit of Jupiter. We call these Trojan asteroids. And actually, we break them up into 2 families. We got the Greeks and we got the Trojans. The Greeks are on the right, the Trojans are on the left. And this is something that comes out of celestial mechanics, that in the orbit of any body around a star, where the orbit is sufficiently far away from the star, you're going to get stable places along the orbit, we call the Lagrange points, where it's possible for a smaller body to share the same orbit if it's about 60 degrees forward along the orbit or 60 degrees back. If it's exactly 60 degrees, you've got a very stable position where it's possible for a smaller body to share the orbit with Jupiter and then never get disturbed from that position. However, if you got other planets involved, they will get disturbed. And so this is not a permanent feature where it's going to last for billions of years, but it can last a long time. And so these Trojans and Greeks are not as numerous as they were, say, 4 billion years ago, but we still have a number of them sharing the orbit of Jupiter, which raises a question. Is it possible for a small body to share Earth's orbit? And the answer is yes. Matter of fact, astronomers have actually found one of these tiny bodies at one of the Lagrange points in Earth's orbit. However, we don't think it's going to be stable. In fact, one theory that's out there for what was responsible for this planet Theia colliding with Earth to form a bigger Earth and a moon as a result is that we had Theia at one of these Lagrange points, 60 degrees back or 60 degrees forward, and how the movement of Jupiter, Saturn inward towards the sun actually caused it to move away from that stable position and begin to slowly creep towards the Earth. It would explain what we now see and the best models for the moon forming event that the collision was a low velocity collision. However, research also supports the idea that Theia was orbiting more distantly from the Earth. And again, the movement of Jupiter and Saturn towards the ice line, and in Jupiter's case, interior of the ice line, actually caused Theia, which was orbiting more distantly, to collide with the Earth. And it's also possible to get a low velocity collision with that as well. However, I think you can imagine how beneficial it is to have this main belt of asteroids thinned out to the degree it is. By having it thinned out, Earth does not get constantly bombarded by asteroids that get gravitationally disturbed by Jupiter, Saturn, Uranus, and Neptune, or a close coming by star to the Earth, and causing massive bombardments on a fairly frequent basis. With a few we see here, we will get bombarded, but we're not going to get bombarded every month or every year. We literally get bombarded about once every 30 million years by an asteroid that's 10 kilometers across or bigger, and maybe once every 10 million years by one that's a kilometer across or bigger. Although if you've been reading Weathering Climate Change, we got 3 such bombardments in just the last 2.5 million years, something we would not at all expect given just how few of these main belt asteroids exist and how far away they orbit the Earth. But yeah, having that E belt cleared out, if that E belt remained to any degree, we'd be in a heap of trouble because we'd be getting a lot of significant collision events. And you say, well, wouldn't it have been beneficial if all of these got cleared out? That would not be the case at all. We actually need to have some of these collisions taking place. I gave a RTB Live talk a couple of weeks ago where I was making the point that it's important that we get a significant asteroidal bombardment. And by significant, I mean something like 5 kilometers across or bigger, happening about once every 30 million years. That way we can get a huge amount of life forms cleansed from the Earth, eradicated, so our Creator God can follow that up and replace those life forms with a whole bunch of new life forms that are more efficient in pulling greenhouse gases out of the atmosphere. And so getting these collisions actually plays a role in explaining how it is that life has been sustained on planet Earth for 3.8 billion years, in spite of the fact that the sun is now 23% brighter than it was at the time of the origin of life. Well, I see that I've gone a little more over than my 30 minutes, so I'm going to stop here. But where I'm going to pick this up is actually explain, this is a quote I was going to give you, but actually explain the benefits that we get from these these asteroid and comet belts. How we get exactly the right number of collisions, not too many, not too few. So why it is we need to have collisions and why it is we don't want too many. So pick it up there next week. And incidentally, one thing I didn't get to is this Grand Tag movement explains the unique water abundance of planet Earth. So I'll pick that up next week, how it is that we're finding planets, rocky planets, that are super rich with water and others that are bone dry. And the only way we know of that has exactly the amount of water we need for advanced life is our planet Earth. And this Grand Tag movement actually plays a crucial role in making that possible. So we'll pick that up next week. And the next week, I think we'll be able to finish our solar system series here, looking at all the fine-tuned designs, not just on the planets we've been talking about the past few weeks, but also looking at the 5 asteroid and comet belts and why it is we look at other planetary systems, we either see no asteroids or comets, or we see thousands of times as many as what we see orbiting our star, the sun. So let me stop share. And give it back to you, Mark and Ross.
Very good, Hugh. Thank you. I just want to remind everybody, if you're new, to use the Q&A if you want to ask Hugh a question, not chat. Also, tell us where you are. It always makes it a little more interesting. And all questions are acceptable for Dr. Ross. They don't have to be pertinent to the topic that he's speaking on. And let's start, Hugh, with a question from Doug here in Monrovia, California. He's referring to the old Art Bell radio show that
Oh, Art Bell, I remember Art, yes.
used to be on KFI here locally. He says, when he was alive, what was that like? Was he responsive to your Christian message?
Well, Art Bell had me on his show several times. You're not familiar with it. It ranks as having the largest audience for any early morning show. And by early morning, we're talking 11 p.m. to 5 in the morning. Although I think they've now cut it back to just a 4-hour show. But when Art Bell was the host, it had 10 million listeners from around the world. So yeah, it ranked as a #1, what they call night owl radio show that was out there. So yeah, and he told me he was an atheist. However, he kept having me back. And if you know anything about that show, I think it's called Coast to Coast AM. And basically, they talk about conspiracy theories, UFOs, things that go bump in the night, things that you have nightmares about. That's what the show is all about. And he had me on one time to debate somebody who thought that physical aliens from other planets were actually planting structures on Mars. So we dealt with that. And but there was one time where he had both Fuzz and me on the show for a full 5 hours. And the last hour, he actually invited us to talk about, well, tell us, how does one become a Christian? And we thought he was very close to actually praying to receive Christ as Creator, Lord, and Savior. He was so receptive to all the evidences that we were giving and how we responded to the atheists that were calling in. I don't know where he wound up spiritually. I do know he got exhausted from trying to host that show and has now turned it over to George Noory. George Noory has also had me on quite a few times. And George is also kind of like Art. He's allowed me to explain the Christian gospel message to the audience. So who knows how God's going to use that.
Thank you, Hugh. And just a question from me, really. When you're going to be on a radio show or something that other people could watch or listen to, maybe you could let us know here at Paradox so we could tune in. There's nothing like more Hugh Ross.
Well, I'll try to do that. A lot of them, especially with this pandemic, what's happening, of course, is both of these interviews are via Zoom or Skype, and often I don't have a lot of notice.
Mm-hmm.
On the other hand, if you go to the reasons.org site, they will give you advance notice when the shows are live. Most of them are not live, they're recorded. And so what I have to do is give you the link when the link is released. And I do that fairly faithfully on my Facebook and Twitter pages. So if people go to my Facebook and Twitter pages, they will get links to those recordings. And where possible, I'll give a link to where it's live. But keep in mind, sometimes I don't know about the live event until 2 or 3 days before. But if I got lots of advance notice, yes, I'll take up their advice and we'll do that right here at paradoxes.org.
Very good. We have an excellent question from Stephen Posta again in Spring, Texas. He says, why did God provide a way of redemption for fallen man, but did not provide a way for fallen angels?
That's a very good question. I would take you back to Genesis chapter 3. Here we got Adam and Eve in the Garden of Eden. They have rebelled against God. They're now experiencing sin and evil. I mean, God gave them a choice. You can listen to me and I'll instruct you about evil, or you can experience it yourself. They chose to experience it themselves when they ate of the tree of the knowledge of good and evil. And when that happened, God banished them from the garden and then prevented access to the tree of life by sending two angels with fiery swords so that Adam and Eve could not get back to that tree of life. That turned out to be a blessing because by allowing human beings to experience physical death, God now had an efficient tool by which he could restrain the expression of evil and actually work on a means by which we humans can be permanently redeemed from our sinful nature. And so physical death is a tool. In this sense, if God had allowed human beings to live physically forever, now in a state of sin like the demons are, the fallen angels, then evil would run completely out of control, and that pathway for redemption would not be possible. It's something I explain in detail in my book, Why the Universe is the Way It Is, how giving us a lifespan, and incidentally, we see a lesson in the Bible. What we see in the first 11 chapters of the Bible are human beings living a lot longer than we live today. And basically the story of what happened before the flood is that you had people with evil intent. We got the story of Cain, where Cain murdered his brother, and then we see the descendants of Cain expressing murder to a far greater degree than Cain did. And if you allow someone who's a serial murderer live for 900 years, guess who he's going to kill? He's not going to be killing other serial murderers. He's going to be killing off the righteous. And this actually explains what happened in the days before the flood, is that righteous people were being preferentially killed off relative to the wicked people. And so very quickly you wound up with a human population that was almost entirely reprobate in their behavior, where there was only one family left, the family of Noah. And God basically started over with the family of Noah. What we see after Noah is we don't live 900 years any longer. The maximum's 120. And that actually helps make sure that we don't have these reprobate people expressing their reprobation for hundreds of years. They only get to express it for decades, and actually restrains the expression of evil and allows people to basically see the benefits of pursuing a pathway of virtue and actually discover, look, I can't live the virtuous life God wants me to live. The law that I see written on my heart, I'm going to need his help. But the problem with the fallen angels is that they don't get to experience death like we do. Literally continue in their current state forever, in which case evil is run out of control to a point where there's no possible pathway for redemption. So the demons will not be redeemed. However, we humans, because we're constrained to the physics of the universe, that's the other factor. These angels are not constrained by gravity, thermodynamics, and electromagnetism. I explain in why the universe is the way it is, why the laws of physics that God has subjected us all to and the whole universe to are crucial to restrain evil enough where we can see God's offer of redemption and basically receive it. And of course, a crucial factor in this is not only do we humans have to experience physical death, but the creator of the universe, the second person of the triune God, Jesus Christ, likewise has to go through physical death so that we can be redeemed. So yeah, we are in a different category than the angels. We die, they do not.
Very good, thank you. The next question is from Keith. I don't know where he is from, but he says, what happened to the remnants of Theia after the collision?
Okay, I explain this in some detail in Improbable Planet. My next book has actually got the latest wrinkles on the moon forming events, some of the new stuff that we've learned, how it explains the interior structure of the Earth to a much greater degree, and that of the moon as well. But basically, you've got this planet Theia that's smaller than the proto-Earth. As I said, 11 to 15% the current mass of the Earth. It collides at a relatively slow velocity, and it collides at an oblique angle, so it's not a head-on hit. It comes in at about 45 degrees. And also, you need to fine tune the rotation rate of the two bodies and the direction of rotation to make this work. But what happens is the merger event blasts away Earth's primordial water, Earth's primordial atmosphere almost entirely. That's a good thing because Proto-Earth started off with an atmosphere that was way too thick and with way too much water to make advanced life possible. So this merger event really fulfills a crucial role, but it also sets up a debris cloud around these two colliding bodies of a relatively light material that coalesces to make the moon. So it explains why the moon has as low a density as it does. It also explains why the moon is so big. I mean, one of the enigmas is that we have this giant moon orbiting a small planet. There's nothing like that in the solar system. I mean, our moon compared to the mass of the Earth is 53 times greater than the mass of Titan compared to Saturn, which comes the closest to matching the moon-planet ratio that we see in the Earth-Moon system. But this collision actually explains the big mass of the moon. It explains its orbit, explains why we have a huge transfer of angular momentum away from the new Earth to the moon. So why the moon is spiraling away from the Earth. And it actually explains our rotation rate because this merger event basically gave us a rotation rate something like 2 to 3 hours per day, maybe even more rapidly. But it's the tidal interaction of this giant moon orbiting our Earth at such a close distance, it slows down our rotation rate to 24 hours at exactly the time when our star, the sun, reaches its most stable luminosity phase and its lowest flaring activity phase. So that timing is all perfect thanks to the mass of the moon. Probably the biggest benefit we get, the formation of this giant moon orbiting our small planet ensures that the tilt of the rotation axis of planet Earth doesn't move much. It basically moves back and forth between 22.1 and 24.5 degrees. Now, if it didn't move at all, that would be a problem because then we wouldn't have an ice age cycle. But what we see in Mars, for example, its rotation tilt varies back and forth by 60 degrees. And that would rule out the possibility of advanced life on planet Earth. So it's thanks to the moon. Matter of fact, I wrote an article many years ago. In fact, I got an abbreviated list in Improbable Planet of all the benefits we gain from this moon forming event and the moon having the features that it does.
Thank you, Hugh. We have another question from Stephen Posta in Spring, Texas. He says, astronomers have imaged 2 gas supergiant planets around a young sun-like star, and I hope you know this number here, TYC 8998-760-1. One of the planets is 14 Jupiter masses, and the other is 6 Jupiter masses. One planet orbits at 160 astronomical units and the other at 320. They claim this system is very similar to the early solar system. But did Jupiter or Saturn ever orbit this far out, or were they ever this massive?
The answer is no to both. They were not that massive. They were no more massive than what they are now, and they were not orbiting at those great distances. You may want to look at this story again because where you get a close match with this system that's recently been discovered is with the star Fomalhaut. I may be mispronouncing it, F-O-M-A-U-L-A-U-T. It's a first magnitude star, and astronomers have discovered it's got gas giants orbiting about that distance, at actually an even greater distance. So in that sense, they found a twin to the Fomalhaut system.
Very good. Thank you, Hugh. Next question is from Brian. He says, does the sun lose mass over time And would that cause the planets to drift outward or maybe be lost altogether? Brian's in League City, Texas.
The sun is losing mass, but it's losing mass at a very, very tiny rate. So tiny that it's not impacting the orbits of any of the planetary systems, not even Mercury. Now, when the sun was young, it was losing mass at a much more rapid rate. Some astronomers believe that the primordial sun may have lost as much as 5 or 6% of its original mass. Some believe that it's probably more in the neighborhood of 1 or 2%. But this mass loss would have stopped by the time that the sun was a couple 100 million years old, maybe 500 million years old. Once it's 500 million years old, once it ignites nuclear fusion, where it's fusing hydrogen to helium at an efficient rate, the mass loss rate drops down to its present level, which is thousands of times less than it was during the first 500 million years. So yes, it doesn't have any effect on that. However, in the future, the sun will begin to lose mass at a more rapid rate. That will happen when the sun becomes a red giant. And when that happens, it'll actually incinerate the Earth. We'll be orbiting inside the Earth, inside the sun. But don't worry, that's not going to happen for at least another 4 billion years.
Thank you. So we've got 2 questions now. So if anyone wants to ask a question, you would probably get it answered in this show. So if you've always wanted to ask you a question, we have this rare opportunity. The next question is from Norm Helgeson here in the LA area. And Norm's got about 5 questions in here. So I'm going to ask the first one. And Norm, if you
one at a time.
begin with the rest, please rephrase them because a couple of them are kind of difficult to, I don't know what you're asking. The first one, he says, gamma ray bursts are regarded as the brightest known events in the universe. What is the difficulty of observing these and how is observing them accomplished?
Well, you need a gamma ray telescope. And we didn't have gamma ray telescopes until the 21st century. So, and gamma rays, if you're not familiar with the term, is referring to extremely short wavelength electromagnetic radiation. I mean, you got the visible part of the spectrum, the ultraviolet, which is a shorter wavelength that the Hubble Space Telescope can access. Then you've got the X-ray part of the spectrum, and we do have orbiting X-ray telescopes, but the shortest of all are the gamma rays. But as you go to those shorter wavelengths, you're also looking at higher energy particles. And so the only way you can observe gamma ray objects is with a telescope that's orbiting above the atmosphere of the Earth. Earth's atmosphere blocks out the gamma rays. So it was necessary to actually build a gamma ray telescope and put it in orbit. There are now several of these platforms that are orbiting the Earth that are observing these gamma rays. And yeah, they've been surprised by what they've been seeing. And probably the big thing they've been noticing is there's objects in the universe that are pouring out very short bursts of gamma rays. By short bursts, anywhere from milliseconds to a few seconds of bursts of these. And they've actually found some that repeat. Most don't repeat. And so there's been a variety of objects. Like, for example, if you get merging neutron stars, that will explain the gamma rays. Or if you've got a neutron star that's got a very high magnetic field and it's accumulating matter, that too will explain these gamma ray bursts. This is an active area of research. We don't have a lot of these objects that we can observe. We're looking at dozens so far that have been observed. And so there's a fairly major effort going on to try to get a large enough observational base that we can actually really begin to figure out what's going on. I've written a couple of articles on fast radio bursts that you'll find at Today's New Reason to Believe at reasons.org. And one of the astronomers that volunteers for us actually is a fast radio burst specialist. So yeah, if you want, I could actually bring him on this show. He lives in San Diego. And so I could actually bring him on to talk about fast radio bursts, if that's of interest to anybody.
Thank you, Hugh. Tim Williams lives in Seattle, and his question is, you often mention factors that rule out advanced life elsewhere in the universe. Does this mean that simple life might be possible in these places, or do you want to avoid the discussion of the possibility of making life anywhere by focusing just on the easier question of advanced life?
Well, Tim, by the way, is part of our Reasons to Believe board. So welcome, Tim. He lives up there in Seattle. And he's raising a very good point that the fine-tuning design requirements for advanced life, I'm referring there to creatures that are like mammals and birds, advanced animals, that the degree of fine-tuning design that's necessary is orders and orders of magnitude greater than what you need to get simple microbes. And also, there's the issue of how long you want those microbes to last. If you go to reasons.org/fine-tuning, that will pop up for you a 300-page compendium of fine-tuning evidence. Actually, at one point in that compendium, I break down the fine-tuning in the context of what's necessary to find a planetary system where you could have one microbial species, a very simple microbial species that exists for 3 months or less. And comparing that to what you need to find a planetary system where you've got microbial life that persists for 3 billion years. You say, why did I pick 3 billion? Well, if you don't have microbes existing on a body for at least 2 billion, and really you need 3 billion years minimum, there's no possibility of getting creatures as advanced as plants and animals. So if you want anything better than just microbes, that explains too why on our own planet, you only have microbes.
Put your hands underneath the
75
pillow.
years ago. So
1, 2,
a
wait,
very good
let's do
orders
it
of
together.
magnitude
1, 2, 3.
than what you would have if you
Go
just
to the
went
bathroom.
for 3 months. And then I talk about what you need to get a planet on which you've got advanced plants, or what you need to get a planet that's got birds and mammals, and what you need to get a planet that's got the equivalent of us human beings. And I'm hoping to develop an update. This has actually been in my book, Improbable Planet. It will especially be coming out in the next book I'm working on, what you need to get human beings that are in need of redemption from the creator of the universe. That's where you see the greatest fine-tuning design of all. And that's really where you see the need, not only to fine-tune our star and our planet and the accompanying planets, we need to fine-tune our galaxy cluster, our galaxy group, our super galaxy. You need to fine-tune the large-scale structure of the universe. You need to fine-tune everything all the way down to fundamental particles. And so it's basically showing us, if you want a universe where billions of human beings can be redeemed from their sin and evil, then literally everything that we observe in the universe, Earth, and Earth's life, in terms of the components and the events, must be fine-tuned to make that possible. But yeah, that's one reason why I've been focusing on advanced life, because we are actually finding planetary systems where we cannot rule out the possibility that you could have microbes existing there for a short period of time. And it's going to take more research to see if we can actually rule out the possibility that they could have microbes existing for more than 1 billion years. But I think we're really close to doing that, actually not only being able to rule out advanced life and plants and animals, but even the possibility that they could have microbes sustained on that planet for more than 1 billion years.
Thank you, Hugh. We have a question from Terry Rathman. He says, how is dark matter considered in the calculations of the past history of our solar system?
Well, my colleague, Jeff Zwirink here at Reasons to Believe, he's a dark matter researcher. He works 1 day a month at UCLA, and he's part of a dark matter research team. And his team is interested not only in the dark matter that we see outside of our galaxy and in our galaxy, but the potential of discovering dark matter even within our sun and our solar system. Because most astronomers believe that this exotic dark matter is ubiquitous, and where can we see it all? So yes, that research is ongoing, but the kind of research is difficult. It's not as easy as trying to detect dark matter in our galaxy and beyond our galaxy, because there we can see the gravitational effects quite easily. You're not going to see the gravitational effects in our solar system. But it's possible it'll be easier to detect the decay of these particles more easily in our solar system than we can, say, in the center of our galaxy. That's a debate that's going on right now. That's considered to be the easiest way to actually detect these exotic dark matter particles, is to look at the decay, because all particles decay to some degree. We don't know the decay rates with any precision. People are speculating about the decay rates, but that gives us the best shot at actually discovering these particles.
Thank you, Hugh. Another question from Stephen in Spring, Texas. He says, do we know when God created the angelic beings? Did he do it all at once, or did he spread it out over a long period of time, like the creation of the universe?
That's a very good question. The really only passage I can think of in the Bible that gives us insight on that is Job 38:7, where it talks about the angels being witnesses to God laying down the foundations of the earth. And as a scientist, we know those foundations were laid down. It's hard to tell what exactly that means. We're talking about the formation of the earth. That's 4.567 billion years ago. If it's referring to when we get the first appearance of continents, that's a little more recent. Basically, you're looking at 3.8 billion years ago. We're talking about the formation of continents covering a significant percentage of the Earth. That's 2.45 billion years ago. But it's basically telling us angels were witnesses to God performing those events. So they've been around for at least 2.5 billion years. That passage could be used if you're interpreting it as God forming the earth. That puts angels back 4.56 billion years ago. But that's about the most that we can discern from the biblical text. It's possible that God created angels before he created the universe. We don't know. The Bible is silent at that point. We do know for sure that angels sinned before we sinned. Satan and a third of the angelic hosts chose to rebel against God's authority. And we know that predates the rebellion of Adam. After all, we got Satan coming to the garden. He was clearly a sinner when he entered the garden. But exactly what time after he was created, he chose to rebel against God, again, we don't know. That might have been well after God created the universe, conceivably as even before God created the universe. We are told in the New Testament that God was performing his works of redemption, beginning to form his works of redemption before he created anything. But of course, you can interpret that the angelic rebellion hadn't happened yet, but God in his foreknowledge knew that it would, and he created the universe knowing in advance that evil would come, and created the universe as such that it could be an effective tool within God's hands to bring about redemption. But it is interesting that we got the New Testament telling us that God was actually putting into effect his redemptive plan, his grace, the hope that he was giving us before he created the space-time dimensions of the universe.
Thank you, Hugh. Brian in League City, Texas asks, how long does it take for a star like the sun to explode? And it sounds like he's focusing on just the explosion part. How long would that take?
While the sun is not massive enough to go supernova, so it's not going to explode, what will happen is it is massive enough that it'll become a red giant star. After it exhausts its hydrogen helium fusion process. Right now, the sun is shining by fusing hydrogen into helium. Basically, it's a gigantic hydrogen bomb, but the amount of hydrogen that it can fuse into helium is limited. The sun's mass tells us that it can do that for a 9 billion year period, which means it's about halfway through its fuel supply right now. And but when it exhausts that, the sun will no longer be producing. It's going to wind up going into another phase of nuclear fusion. Actually, it's fusing a little bit of combining helium into carbon, nitrogen, and oxygen. About 0.5% of the energy coming to the sun is coming from that process. But when hydrogen fusion stops, it's going to entirely go into what's called the carbon, nitrogen, oxygen cycle, where it's basically fusing together helium nuclei to make carbon, oxygen, and nitrogen. And when that happens, the sun is going to get much bigger than it is now. It's going to get big enough that it'll actually encompass the orbits of Mercury, of Venus, and the Earth. And so there will come a time when the sun will become so big that it'll vaporize Mercury, Venus, and our planet Earth. And then that fuel supply will be exhausted. And when it is, our sun no longer will have the energy output to stop the contraction of the sun through gravitational forces. And so it's going to shrink down, and it's going to shrink down and become a white dwarf star. It's not going to explode. It's not going to become a supernova. It's not going to become a nova. It will end its life as a white dwarf. And a white dwarf star is a star that's no longer producing energy through fusion. It's simply producing energy through the release of leftover heat. Think of a log that you have on an open fire. There comes a time when all the fuel in that log gets exhausted, and what you have left over is an ember. And it starts off as a bright red, and then it goes down to kind of an orange color, and eventually it cools off and becomes a black piece of, just, kind of what we call a coal, black coal. And so that will happen. Eventually our star will become a white dwarf, in which case it'll just be cooling down, and then it'll eventually go black. But what's interesting is we astronomers do not see a single black dwarf star. The universe is not yet old enough for a star to completely cool down and become black. And so the really old stars are white dwarf stars.
Thank you, Hugh. Susan Lambeau asks an excellent question. She says, if simple life forms occur on other planets, are you suggesting that abiogenesis occurs, or that God would have started primitive life on other planets as well?
Yeah, the answer to Susan's question is the latter. I mean, Buzz Ron and I regularly attend, in fact, we attend all the Origin of Life research conferences that are held here in North America. And what we learn from those conferences and reading the scientific literature, it takes the supernatural hand of God in order for these biochemicals to come together and make a life form. Even the simplest microbial life requires a supernatural hand of God. In fact, I wrote an article on this recently in today's New Reason to Believe, written by a leading Origin of Life researcher, where he basically says, we Origin of Life chemists have made amazing progress in the laboratory showing how we can take these simple prebiotic molecules and be able to manufacture them to make amino acids and nucleobases and even sugars. And we've even been able to take these amino acids we've manufactured and join them together to make short chains of amino acids. Nothing like a protein, but we can make a chain. But I think the record is they've been able to make one that was 50 isomers long, in other words, joining together 50 amino acids. But what this researcher in the British journal Nature declared is, to do this, we have to commit the hand of God dilemma. In other words, it takes a very intelligent chemist with highly technical equipment in a highly controlled laboratory conditions We make sure no interfering chemicals get in the way. We only use pure starting chemicals, and we carefully control things so that we only get constructive reactions, not destructive reactions. And he basically makes the point, this won't happen unless you've got the hand of God operating. In other words, someone very intelligent, highly equipped, and they're controlling everything to pull it off. And he's actually encouraging his fellow Origin of Life researchers, when you publish a paper, please state how many times in your experiment you commit the hand of God dilemma. But he concluded his paper by saying, it's never going to be less than a dozen times. And therefore, we need to stop deceiving ourselves into thinking we're actually figuring out how this happened in nature without the agency of an intelligent being. And what's interesting was this fellow who wrote this paper was not a believer, but he was basically challenging his fellow Origin of Life researchers. We need to be honest with the lay public about the difficulties we're facing, and that we need to stop trying to communicate that this is something that would happen easily in the world of nature without any kind of experimental control. So in that sense, I would answer Susan's question by saying, we could find life on other planets, but if we do, it's because God created life there. It's not because it happened naturalistically. And I've got fellow Christian astronomers who are actually hoping that we do find life. Because it says if we find life on another planet, that's going to give us double the evidence that God has intervened to make it all happen, because of the overwhelming evidence we have that it can't happen naturalistically. And publicly, I've been on record since the 1980s. We will find the remains of life on every solar system body if we look hard enough for it. Why? Because life has been so prolific on Earth for so long that bombarding meteorites and asteroids have caused some of our life to be exported throughout the solar system. Matter of fact, astronomers I know have published papers where they calculate that 20,000 kilograms of Earth's soil has been transported to the moon by this means on every 100 square kilometers of the moon's surface, which is why I wrote an article years ago, and it's still up on our website, saying we need to go back to the moon with a different mission, because Earth's geology has destroyed the fossils of Earth's first life. But the fossils of Earth's first life will be on the moon's surface in pristine form, because the moon has had almost no geological activity. If we go back to the moon, we have a very good chance of finding the fossils of Earth's first life. And that will tell us who got the origin of life right, the theists or the non-theists. I actually delivered a lecture on this to the NASA community at Houston, and basically challenging them. I know you're all focused on going to Mars. That's got a lot of technical difficulties, as we've already talked about today, but we can go back to the moon, and we go back to the moon with a different mission that's really going to excite the taxpayers. Because the last time I checked, non-theistic taxpayers plus theistic taxpayers made up 100% of the US taxpayer base. And they all have a vested interest in seeing who got it right, the theists or the non-theists, because the two groups predict very different things about what the fossils of Earth's first life should look like. Can we do it on Mars? Yes, we can, but it's going to be far more challenging because not nearly as much Earth soil has been transported to Mars.
Would you please repeat the name of the author of the Origin of Life paper that you were just talking about?
Oh, I was referring to actually hundreds of research papers.
Okay.
This one. Incidentally, we put in the new edition of our Origins of Life book a URL on our website where we actually catalog all the articles that Buzz and I have written on the origin of life. And that URL actually takes you to more than 200 articles that we have written. We also archive their video clips that we've done on the origin of life. And if you put in Origins of Life archive, I think you can get it on the website. But yeah, it's in two places at the beginning and the end of our latest edition of our book, Origins of Life.
We've got 1 minute left. Norm Helgeson has another question, and he's referring to something I'm not sure what it is, so hopefully you'll be able to get it. He says SMBHs rank as the brightest locales in the universe. How do these energy levels compare with gamma ray bursts?
Okay, that's a short acronym for supermassive black hole. And all galaxies have supermassive black holes. In fact, I've got a chapter in my next book on supermassive black holes, basically talking about how uniquely designed the supermassive black hole in our Milky Way galaxy is compared to that of all other similarly sized galaxies. Bottom line is, we got a really tiny supermassive black hole, and it's an enigma how it is we got such a tiny supermassive black hole. But yes, supermassive black holes can be incredibly bright objects. Matter of fact, that's what a quasar is. A quasar is a supermassive black hole in a galaxy, a giant galaxy, where the supermassive black hole is aggressively accreting matter. And so these very bright objects, quasars, that's what they are, supermassive black holes. To give you an example, there's a galaxy in the Virgo cluster, M87. It's got a supermassive black hole that weighs in at 6.5 billion times the mass of our star, the sun. To compare that with our Milky Way galaxy, ours is only 4 million times more massive than our star, the sun. The one in M87, 6.5 billion times, and it's in an ellipsoidal galaxy. In ellipsoidal galaxy, the stars are jammed much more tightly together. And so this is a supermassive black hole that's eating stars. And when it eats a star, it blasts out a lot of energy. Because what happens is as matter comes close to the black hole, just outside the event horizon of that black hole, that matter is being converted into energy with about 10% efficiency. And our sun, for example, converts matter into energy with 0.07% efficiency. So this is orders of magnitude greater than what we see inside our sun, and explains why quasars are so incredibly bright. By the way, one of the things that's really helpful is, as far away as M87 is, more than 50 million light years, if it's supermassive black hole, it's basically pouring out these giant jets of energy, and one of them is highly collimated. If that were aimed right at us, our civilization would not be possible. But fortunately, it's pointed away from us, so we can observe it. It's the closest supermassive black hole that's pouring out copious amounts of intense energy that we can observe. And it's actually the first object where astronomers, radio astronomers, were able to map the event horizon of a black hole. That got published about a year ago.
Well, Hugh, we got through all the questions, and thank you again for a great show. Would you please close us in prayer?
Sure. Father in heaven, just thank you for these great questions we're getting from people. And Father, I pray that all of us would use what we see in the record of nature as a means to persuade people to examine what you revealed in the book of Scripture. And Father, we thank you that we're living at a time, the 21st century, where revelations from the book of nature are literally exploding. And so, Father, we thank you for that revelation, and pray, Father, that you would give us the humility and the grace to be able to submit to what we see you revealing through that nature. Lord, that as a result, we would receive more of your love, your life, and your truth. And Father, I pray that you present us with opportunities to share what we learn with others, so they too can be a partaker in that truth, life, and love. In Jesus' name, amen.
Thank you, Hugh. Have a good week.
Thank you. I'll stop the recording. And thank both of you for helping me with this.